The motherboard is often called the heart of a computer system, but it's more accurate to think of it as the central nervous system. This complex circuit board connects and enables communication between all the components that make your computer function. But how exactly does it work? At its core, a motherboard is a printed circuit board made of layers of fiberglass, copper traces, and other materials. These copper pathways act like highways, allowing electrical signals and data to travel between different components. The board itself provides both physical support and electrical connections for everything from your processor to your memory and storage devices. The most prominent feature on any motherboard is the CPU socket. This specialized connector securely holds your processor in place while providing hundreds of precise electrical connections. Surrounding this socket are voltage regulators and capacitors that ensure your processor receives clean, stable power at exactly the right voltage. Memory slots, typically located adjacent to the CPU socket, connect your RAM modules to the system. These slots are connected directly to the memory controller, which may be integrated into the CPU or chipset, allowing for high-speed data transfer between your processor and memory. The chipset is the motherboard's traffic controller, consisting of one or two chips known as the North Bridge and South Bridge in older designs, or a single platform controller hub in modern boards. This crucial component manages data flow between the CPU and other components, determining which signals go where and when. Expansion slots like PCI Express provide connections for graphics cards, sound cards, and other add-in components. These slots connect directly to the chipset and provide standardized interfaces with different bandwidth capabilities, depending on their generation and lane configuration. Storage connectors such as SATA or M2 ports link your storage devices to the system. These interfaces connect through the chipset and allow data to flow between your storage drives and other components. Modern motherboards often include multiple types of storage connections to support different drive technologies. The BIOS or UEFI firmware, stored on a small chip, contains the fundamental instructions that tell the computer how to access its hardware and boot the operating system. This firmware runs automatically when you power on your computer, initializing hardware components and performing system checks before handing control to your operating system. Power distribution on a motherboard is handled through multiple layers. The main power connector, usually 24 pins, brings electricity from your power supply to the motherboard. This power is then regulated and distributed to various components through a complex network of power planes and voltage regulators that ensure each component receives exactly the electricity it needs. Data travels across the motherboard through buses, which are collections of parallel wires or traces that carry address information, control signals, and data. Different buses operate at different speeds with high-priority connections like those between the CPU and memory running at much higher frequencies than peripheral connections. Motherboards come in standardized form factors like ATX, micro-ATX, and mini-ITX, which define their physical dimensions, mounting holes, and component layout. These standards ensure compatibility with cases, power supplies, and other components, allowing system builders to mix and match parts from different manufacturers. The front panel connectors link your computer case's power button, reset switch, and indicator lights to the motherboard, while USB headers, audio connectors, and other front panel headers allow case ports to connect to the motherboard's internal systems. Modern motherboards also include integrated components like audio processors, network controllers, and sometimes even graphics processors, reducing the need for separate expansion cards and simplifying system design. Understanding how a motherboard works reveals the remarkable engineering behind every computer system. This complex orchestration of electrical pathways, connectors, and controllers forms the foundation upon which all other computer components operate, making the motherboard truly the most essential component in any computer system.